All right, let's just jump right in. We are going to talk about one of the most famously weird, absolutely mind-bending concepts in all of physics, superposition. Seriously, this idea is at the very heart of quantum mechanics, and it pretty much challenges everything we think we know about reality. And you can't even begin to talk about superposition without asking the classic question, right? That poor cat in a box. Is it actually in some strange zombie-like state of being both alive and dead until we open the lid and look? It's the ultimate physics paradox. But here's the thing. To really get to the bottom of all this quantum weirdness, we're not going to start with cats or atoms. Nope. We're going to start with something way more familiar, something you're probably experiencing this very second: sound. So what is this thing really? Well, at its core, superposition is all about how things that act like waves combine, how they interact with each other. But as you're about to see, there are two very different flavors of this idea. Okay, so first up, you've got wave superposition. This is the one that applies to things like sound waves, light waves, ripples in water. This is the classical, everyday version you already know. But then there's quantum superposition, and that's the one that describes how tiny particles can somehow exist in multiple states all at once. Yeah, that's where it gets really strange. So let's stick with the world we actually know for a minute. Classical superposition. I mean, it's happening all around you all the time. It's really just a simple idea of adding physical effects together. Think about what's happening right now. Your ear is literally performing superposition. It's taking the sound waves from my voice and maybe the hum from your computer, and it's just adding them together into one single combined wave that hits your eardrum. It's not magic, it's just math. It's just addition. And when you sum up waves like that, you get this really cool effect called interference. The perfect example is tuning a guitar. You know when two strings are almost in tune, you hear that wah 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 sound? That's because the sound waves are sometimes lining up and getting louder and sometimes opposing each other and getting quieter. That pulsing wobble, that is the sound of classical superposition in action. Okay, so we've got the basics down. Now, take a deep breath, because we are about to take a quantum leap into a completely different kind of logic, a place where the rules of reality itself just seem to change. And right here, this is the crucial difference. Classical superposition adds up physical things, right? Like sound waves hitting your ear. But quantum superposition, it adds up abstract possibilities. It's not a sum of what is, it's a sum of what could be. And that's the part that bends your brain. We're not just adding waves in the air anymore. We're talking about adding different, totally incompatible outcomes together. It's like saying the answer isn't just A or B, it's some combination of the reality where A is true and the reality where B is true. So, what does this new kind of logic actually look like when we apply it to the real world? Let's walk through a couple of classic examples that really show these new rules in action. Okay, I know this diagram looks a little intense, but the key idea is right there in the caption. X and Y are one way to look at things, but U and V are another equally real way. Think of it like this. You can ask, is the electron at position X or Y? That's a valid question. But you could also ask a totally different question, like, does it have property U or V? Quantum mechanics says both ways of asking are equally valid frames of reality. And the weird part? The U state is actually a combination, a superposition, of the X and Y states. It's just a different but equally true perspective. Here's another perfect example, electron spin. So let's say you measure an electron spin on the z-axis. Boom, you get a clear answer, maybe up. But now what happens if you measure its spin on the x-axis? Well, you get a clear answer for that too, but in the process, you've completely destroyed the information about the z-spin. It's gone. Why? Because the x-spin state is a superposition of the z-spin states. They are different competing realities, and you can only know one of them at a time. So after all of this quantum weirdness, what's the big takeaway here? Why does any of this matter for how we understand the world? Well, the real meaning of superposition, it might not be what you think. This is it. This is the punchline. According to physics, the statement that something is in a superposition is actually meaningless all by itself. It's not some magical state that a particle just decides to be in. It's all about your point of view. It's all relative. An electron that has a definite x spin is only in a superposition of z spins if you insist on describing it from the z spin's perspective. From its own perspective, its x spin is perfectly clear and defined. See, superposition isn't really a state of being. It's a relationship between different ways of looking at the exact same thing.
Which brings us all the way back to the cat. It's not really alive and dead. It's that the quantum state of the whole system is in a superposition relative to our classical, everyday frame of alive or dead. And that leaves us with one last, really fascinating question to think about. If the nature of reality itself depends on the questions we choose to ask, then what does it truly mean to be real?